All right, in this session, I want us to check the concept of geometric sequence. So this is given by Tn is equals to Arn minus 1, okay? So whereby the Tn shows you the value of that term, and then A is our first term, and then whereby we have R, which is our common ratio, and then N is still the position, is the position of that term, and then 1 is just a number. Okay, so this is a kind of pattern whereby we no longer have a difference, but we have a ratio. Okay, suppose we're given this kind of pattern. Okay, so you're having 2, 4, 8, 16, 32. Okay, let's stop there. Okay, so notice how we move from the first term to the second term. Okay, or from one term to another. So you can see that you can see the trend that when we move from this term to this term, we multiply the previous term by 2. We also multiply the previous term by 2, and then in that way, that is how the pattern grows. Okay, so it means that these two, it's our common ratio. So how do we get our common ratio? Our common ratio, our R, it's given by T2 divided by T1. Okay, because if you can check, if you can take 4 and divide it by 2, you will get the exact value there. Okay, so similarly, for confirmation purposes, we know that T2 divided by T1 should also be equals to T3 divided by T1. Okay, this is for confirmation purposes. All right, or for simultaneous purposes as well. Okay, so here we know that our R is equals to 2. Okay, so we can determine the general formula for this, because we already know that our A value is equals to 2, our R value is equals to 2, and this is the information that we need. Okay, so in this case, it means Tn is equals to 2, which is our A value, open bracket, 2, which is our R value, to the exponent n minus 1. And then you leave it like this. This is your general rule. Do not ever in your life multiply the two, because they are not, don't multiply the two, because this one is carrying an exponent here. So when you multiply the two, what are you trying to do? Okay, so since we know the general rule, we can check whether this works. Okay, so we can check for term number 1. Then we're going to have 2 into 2 exponent 1 minus 1, because we're looking for term number 1. It means the value of n here is 1. So now in this case, we're having 2 into 2, then the exponent will give you 0. So any number raised to exponent 0, it's 1. So it means we're going to have 2 into 1, and then it gives you 2, so which is the first term. And then we can also check for term number 3, and then we're having 2 into 2, then 3 minus 1, then we're going to have 2, 2, then exponent 2, then 2 squared, it's 4, 4 multiplied by 2, it's 8. And then you can see that term number 3 is 8. Okay, so this is how we can apply this general rule for the geometric sequence. Okay, so we can look at an example for now, so that we can see that we really understand this concept of geometric sequence. Okay, here's our example. The first 3 terms of a geometric sequence are, we are given 16, we are given 4, and we are also given 1. So calculate the value of the 12th term, and then you can leave your answer in the same simplified exponential form. Okay, they want you to determine T12. This is what the question is looking for. Okay, so remember, now we are dealing with what? With geometric sequence. So in mind, we already know that Tn is equals to a r exponent n minus 1. Okay, so it means we have to find the a value, which we already know that the a value in this case is 16. So we need to find the r value. So how do we find r? We know that r is equals to T2 divided by T1. Okay, so T2, it's 4, and then we divide this by term number 1, which is 16. Okay, so then we get that our r value is 1 over 4. Okay, so for confirmation, you can say r is equals to T3 minus T2, and then this is 1 over 4. So this is our common ratio. Okay, so now we can substitute here. It means our general formula, it's our a value is 16, and then our ratio is 1 over 4, then exponent n minus 1. So we got the general formula. Then now we can answer the question saying calculate the value of the 12th term. So we're looking for T12. So T12 is equals to 16 into 1 over 4 exponent, then our n is 12 minus 1. Then they said we must leave this in the simplified exponential form. So you don't need to press your calculator, you just have to simplify this expression here, and then the exponent here it's 11. So this is term number 12. This is what the question was looking for. Okay, so we can check on another example. Okay, consider the geometric sequence whereby you are given 4, 2, and 1. Okay, so the first question says determine the determine the next term of the sequence. Okay, so how do we move from this term to this term? Okay, you can see that there is a division there. Every term is divided by, it's reduced by half. Okay, so in this case, to find r, because this is a geometric series, a sequence, so it means we're going to say T2 divided by T1, and then our T2 is 2, then term number 1 is 4, then this is 1 over 2. Okay, so our r value is 1 over 2. So if you can check, when we say 4 multiplied by 1 over 2, we get 2. Okay, then we multiply this by 1 over 2, we get 1. And then when we multiply 1 multiplied by 1 over 2, we get the next term here. And the next term in this sequence, we're going to multiply 1 by our ratio, and then we get 1 over 2. So this is the value of the next term. Okay, so the value of the next term is equals to our r value. Okay, so number 2, determine n if the nth term is equals to 1 over 64. So they want the value of n, but in this case our Tn value is equals to 1 over 64. Okay, so it means that we must find the value of n from the geometric sequence. Okay, so remember, geometric sequence Tn is equals to a r n minus 1. Okay, so our Tn value, we know it. So what is our a value in this case? Our a value, it's 4. Okay, so our Tn in this case is 1 over 64, which is equals to our a value here. The first term is 4, then we're having 4, then our r value is 1 over 2. Okay, 1 over 2 exponent n minus 1. Remember, we're looking for n. Okay, we want the position of this value. Okay, if you are given tn is the value. So if we are looking for n, we are looking for the position of that value. Okay, so in this case, we need to simplify this equation. All right, so how do we simplify this equation? Okay, so we divide both sides by this a value, or by 4. Okay, so we can divide both sides by 4. Okay, so it means that when you work this out on your calculator, you will get that this is 1 over 256, which is equals to half exponent n minus 1. Okay, so we can change this to exponential form. Okay, so it means we're going to have 256 to the power minus 1. Okay, so this is equals to, even this side we can change this fraction to be 2 to the power minus 1, and then n minus 1. Okay, so remember the rule that when you are having an expression like this, we multiply the exponent. Okay, so when we multiply the exponent here, we're going to have 2 to the power minus n plus 1. Then remember, on this side we're having 256 to the power minus 1. Okay, so we can change this 256 to a base exponential form, or to a base of 2. Okay, so when we do that, you can press your calculator and say 256. Okay, you can leave the negative 1 for now, and then you say shift fact, and then it will give you 2 raised to exponent 8. But in this case, it means it will be like this, to the power minus 1. Okay, remember this negative 1, we left it out on the calculator. Okay, so this is 2 to the power minus n plus 1. Then we can multiply this. Okay, so we are going to have 2 to the power minus 8 is equals to 2 minus n plus 1. Then when we are having the same base, we can equate the exponents. So our exponent in this case becomes like this. Then we can take this one to the other side. We're having minus 9, which is equals to minus n. We can divide both sides by negative 1, and then we are going to have n is equals to 9. So this is the value of n that we've been looking for. So the position of this value here, it's number 9. Okay, so this is the value that we are looking for.